Okay, good afternoon to everyone. So this is our fourth lab session, I hope so. So in this session, we are going to conduct the experiment on adder subtractor circuit. Okay, 4-bit binary adder subtractor circuit. Fine. So before getting into the experiment, we have to know some basic things, okay, as a prerequisite section. So this is our experiment 3B, not fourth one, experiment 3B. Right? So the aim is to design and implement 4-bit binary adder subtractor circuit using digital IC 4008. Okay, 4008 is a 4-bit binary adder circuit. Okay, using that, we are going to implement binary adder subtractor circuit. So what is the minimum number of full adders required for an n-bit binary adder? And you people type it in the chat. How many number of full adders are required to construct a n-bit binary adder? Can you type it in the chat? See, if I want to design a 4-bit binary adder, how many full adders are required? போன வீக் தான் CA எழுதியிருக்கிறோம். See, kindly respond. Ma'am, are they typing?
No, sir.
No. Okay. Okay, I will reveal the answers. See, 30 to 40 minutes only we will be having this lab session. So kindly cooperate. So we need n number of full adders. Okay, or n minus 1 full adder plus 1 half adder. Fine. Given two n-bit binary numbers a and b, what is an alternate method to perform the operation a minus b? How it is performed? How we can perform a minus b? Another way. Is anybody is having the answer? During class committee meeting, you people only told continuously if we are taking theory and lab, it's difficult for you. But you people not responding, even we split the session. Don't know why. Yes, Srihari, very good. 2's complement, what? Yes, a plus of minus b. Okay, so minus b is nothing but 2's complement of b. So a plus 2's complement of b is the correct answer. Thank you, Srihari. What is the mode of operation of a binary adder circuit when the initial carry is set as 1? Whether it will work as an adder or subtractor. Initial carry is 1. 0 for adder, very good. So 1 for subtractor, very good. By setting carry as 1, whether subtraction of two numbers can be performed using 1's complement addition? The previous question's continuation. Yes, by setting initial carry as 1. How many bits are required to represent the result when two n-bit numbers are added? So n plus 1 bits, n-bit sum and 1 bit carry out. So these are the components required to build the 4-bit binary adder circuit. Okay. Here NOT gate is not needed because we are going to design only adder subtractor circuit. We are not going to design only 4-bit binary subtractor. We are going to design 4-bit binary adder cum subtractor. Fine. You people kindly type what are the things we need. So instead of 4 full adders, we are having an IC 4008. It is going to perform 4-bit addition operation. Fine. Then XOR gate we need. No need of NOT gate. Then switches for input, LEDs or bulbs or output. Can you take a screenshot of this? Yes, shall we proceed? is the pinout of the XOR gate. Already many times we have shown this. So kindly take a screenshot of this. Okay, next. Not yet not required. Okay, then kindly take a pinout of this IC 4008. This is the pinout of IC 4008. Kindly take a screenshot. So we told can add two 4-bit numbers. Fine. So in that you can see A1, A2, A3, A4. Okay, are the pins for one data, 4-bit data. Then B1, B2, B3, B4 are the pins for second data input. Fine. Then S1, S2, S3, S4 are nothing but the sum output of the addition of A and B. Fine. Then C1 is the initial carry and the C0 is the final carry out. Then for power supply we are having two pins VDD and VSS. Is it clear for everyone? So it is having the provision to add two 4-bit numbers and produce a result as a 4-bit number plus a carry. Right? It is additionally having a carry input. Is it clear for everyone? Have you got an idea how to use this IC? So for A1, 2, 3, 4, இந்த 4 பின்ல நான் என்ன பண்ணணும்? We have to give the inputs A1, A2, A3, A4. Actually, when we are teaching, we taught you like A0, A1, A2, A3, but here it is A1, A2, A3, A4. Fine. Then the input B must be given through an XOR gate, which must be controlled by a line like this. Here, this IC is 4008. Okay, for XOR gate, what is the IC number? 7486. So for building this portion, we are going to use 7486. So this circuit only we are going to implement today. This is the circuit we are going to implement today. So we need 4008 IC and 7486 IC. 7486 is XOR gate IC. 4008 is 4-bit binary adder circuit. Fine. Yes, it is CMOS IC. This one is CMOS IC. Okay, this one is TTL logic kind. Okay. See, in the case of TTL or CMOS, both are available in 5 volt. Okay, 5 volt la operate ஆகிற மாதிரி ரெண்டு ஐசியும் இருக்குது. Fine. But TTL அப்படின்னு சொல்றப்ப definitely 5 volt தான் இருக்கணும். வேற CMOS அப்படின்னு சொல்றப்ப it can be operated in 5 volt as well as 3.3 volt. Okay. It is mentioned in the data sheet. Kindly refer the data sheets. Fine. So this is the output table of adder cum subtractor. So this is the output we are going to verify. See, in our case it is A1, A2, A3, A4 in the IC, but we are going to name it as A0, A1, A2, A3, B0, B1, B2, B3 like that. Fine? Is it clear for everyone? Will we design the circuit? Okay, let's try in logic circuit simulator code. Kindly take a screenshot of this. You must have a screenshot. Kindly take a screenshot of this circuit. So this is the circuit we are going to implement today. Fine. So now I am going to start present from my mobile phone. Fine. So now I am going to present it from my mobile phone. Is my mobile screen is visible for all of you? Yes? Okay. Okay, now we will design the 4-bit binary adder subtractor circuit. So what are the things we need now for build the circuit? First of all, I am going to name it as 3B, experiment number 3B, 4-bit binary adder slash subtractor. So this is 3B experiment. Okay, so what are the IC we need now? Kindly type it in the chat. We are going to conduct this experiment alone. Yes, XOR gate we know. So I am going to go for IC. IC la போயிட்டு நான் என்ன பண்ண போறேன்? Going to take XOR gate. And XOR gate எடுத்தாச்சு. What about the another IC I have to use? 4-bit binary adder. So அதுக்கு என்ன நம்பர் சொன்ன ஞாபகம் இருக்கா? CD 4008. 4-bit binary adder. Okay, fine. So we have taken one XOR gate. Okay, then we have taken 4-bit binary adder. So now what we have to do? We have to give a 4-bit input. Okay, the data A to the pin A1, A2, A3, A4. But நம்ம எப்படி நேம் பண்ண போறோம்? A0, A1, A2, A3. Because நம்ம truth table அப்படிதான் போடுறோம். Fine. So I'm going to take 4 switches for data A. 1, 2, 3, 4. Fine, I am going to rename the switches A3, A2, A1 and A0. Fine. So here what I have to do is I have to use nodes for proper connections. Proper connection காக நம்ம என்ன பண்ண போறோம்? Nodes use பண்ண போறோம். I'm going to take 4 nodes. 4 node எடுத்தாச்சு. Fine. First I am going to connect A0. So connect click பண்ணிட்டு A0. So it must be given at A1. Please remember நம்ம எப்படி choose பண்ணிருக்கோம்ன்றதை நான் சொன்னேன். So A0 ன்றது நமக்கு பொறுத்த வரைக்கும் என்னது? A1 of the IC. So A0 முடிஞ்சது. Next A1. A1 must be connected to A2. நம்மளை பொறுத்த வரைக்கும் என்ன பண்ணிருக்கோம்? A0, A1, A2, A3 எடுத்திருக்கோம். Please remember that. But IC பொறுத்த வரைக்கும் it is A1, A2, A3. Then A2, it must be connected to A3. Fine. Then A3 must be connected to A4. Okay, fine. So A input we have provided. Next, what we have to do? We have to provide B, input B. Okay. So how we have to provide input B? XOR gate, through XOR gate. Very good. So what I am going to do is the output of the XOR gate 1y, 2y, 3y and 4y. I am going to connect it to the another input D. Say for example, what I am going to do is I am going to use 4 more switches. I'm going to copy the switch and paste it. I'm going to paste it here. So மேல உள்ளது என்னது A என்ற டேட்டா, கீழ உள்ளது என்னதுப்பா B என்ற டேட்டா. Similarly, I'm going to copy the nodes. Copy, paste. Okay. See, I must be having one more switch. And you people tell for what? Circuit path சொல்ல முடியுமா? இந்த switch நான் எப்படி rename பண்ண போறோம் அப்படினு பாத்தீங்கன்னா so this can be B3 this one can be B2 this one can be B1 the last one is B0. Okay, so now what I am going to do is I am going to connect all the switches as one of the input to all the XOR gate. So now I am going to connect B0. I am going to connect as 1A. This mode. Fine. So next what I am going to do is I am going to connect the second input B1 to 2A. 2A la connect பண்றேன். Fine. Then the third input B2 அதை கொண்டு போய் எங்க பண்றேன் 3A ல கனெக்ட் பண்றேன். Fine. Then B3 கொண்டு போய் நான் எங்க கனெக்ட் பண்ண போறேன் 4A ல கனெக்ட் பண்றேன். So for proper connection changing the position of the node. So I have to use one more node, I think so, for this connection. I'm going to delete this. One more node I have introduced. I'm going to connect this node here, this node to 4B. Is it clear now for everyone? So first input direct கொடுத்தாச்சு, second input நான் என்ன பண்ணிருக்கேன் XOR gateல ஒவ்வொரு இன்புட்டுக்கு ஒவ்வொரு switch கனெக்ட் பண்ணிட்டேன். What about the other switch? Data A, data B கொடுத்துடலாம். What about other switch? Diagram பார்த்து சொல்ல முடியுமா? M அப்படின்னு சொன்னா ஞாபகம் இருக்குங்களா? We told M அப்படின்னு சொன்னா M equal to 0 னா add, 0 னா subtract ன்னு சொல்லுவோம். கரெக்ட்டுங்களா? So that is the second input of all the XOR gate. So I'm going to connect one switch. So this I'm going to use it as M. Going to use this switch as M. So M நம்ம என்ன பண்ண போறோம்ப்பா? We are going to connect as a second input. இதுக்கு நம்ம இது வழியா கொடுத்துக்கலாம் node வந்து. One node we are using. M is given as a second input to all the XOR gate IC. 3B, 4B. Is it clear for everyone? Here one of the line is overlapping, so I'm going to use one more node here. Delete. Delete. I'm going to use one more node. I'm going to place it here. See, connection வந்து clear-ஆ புரியுற மாதிரி கொடுங்கப்பா, அப்பதான் புரியும். 3B ல கொடுத்தாச்சு. The same thing I'm going to give it to 4B. So now the outputs 1Y, 2Y, 3Y, 4Y. இதை நான் எங்க கொடுக்க போறேன்பா? Where I'm going to give? I'm giving us the second input, 4-bit input. கொடுக்கலாங்களா? So from 1Y, I'm going to connect it to V1. Fine. Then I'm going to use one node. So from here, I'm going to connect 2Y. So 2Y எடுத்துட்டு போய் நான் எங்க கொடுக்க போறேன்? V2 ல கொடுக்கணும். Fine. Then one more node I'm going to use. I'm going to connect 3Y. Okay, 3Y. அது எங்க கொண்டு போய் கொடுக்கணும் பண்ணுங்க? 3Y has to be connected to V3. So I have to connect it to here. I'm connecting like this. Okay, 3Y to V3. Then one more output is there. That is 4Y. It is connected to V4. So two inputs A and B கொடுத்தாச்சு. A is directly coming. B என்ன பண்ணிருக்கோம்? XOR பண்ணி கொடுத்திருக்கோம். XOR with M. All the inputs of XOR gate. One input of XOR gate is connected to M. The other inputs are connected to the corresponding data B. Fine. So one more thing we have to do. இன்னும் ஒரே ஒரு விஷயம் பண்ணணும். என்ன அப்படின்னு பாத்தீங்கன்னா, this M must be given as C in. So M ல இருந்து நான் என்ன பண்ண போறேன்? C in க்கு ஒரு கனெக்ஷன் எஸ்டாப்லிஷ் பண்றேன். இதுக்கு ஒரு நோட் யூஸ் பண்ணிக்கிறேன். I'm going to use one node. So here I'm placing. From here, connecting to this node, this has to be connected to C1. Fine. So now the outputs are C0, S1, S2, S3, S4. So in our case, it is S0, S1, S2, S3. So I'm going to use LEDs. That means light. 4 lights I'm going to use. 5-1. So I'm going to place So this can be S3, S2, S1, S0. Okay. So the last one may be S0. So I'm going to connect this to S1. The next one is, we can use nodes for this. 5 nodes we have to use. 1, 2, 3, 4, 5. The 5 nodes I am taking. 1, 2, 3, 4. Okay. So now we are going to connect. So S0, it must be connected to S1, because in our input variable S0 is the least significant bit. And next, this has to be connected to S2. Then we have to connect S3. That is our S2. So this is our S4. Fine. This final thing is final carrier we have connected. So now I am going to rename this outputs. This one is C out. This one is S3. This one is S2. So another 5 minutes we will find out. This one. And last one is S0. That's it. So now the circuit connections are over. So for performing addition, so initial carry, that means M. So the M நம்ம என்ன பண்ணிருக்கோம் initially off பண்ணிருக்கோம், கரெக்ட்டுங்களா? I hope everyone can visualize this. So now I am going to give 5 plus 5. So A2 and A1, sorry A0, here B2, B0. So 5 plus 5 is 10. 10 is nothing but 1010. Sum மட்டும் பாருங்க. 1010 வருதுங்களா? Is it clear? Okay. Suppose if I am going to give the input as 5 plus 15. 5 plus 15 என்னப்பா? கீழ வந்து பாருங்க 1111 கொடுத்தாச்சு. B ஏல என்ன கொடுத்திருக்கோம்? 0101 கொடுத்திருக்கோம். So 5 plus 15 is 20. So அதை வந்து நம்ம ரெப்ரசன்ட் பண்ணா என்ன வரும்? 10100. வந்திருக்க பாருங்க அவுட்புட்ல. கேரி தான் என்னோட MSB மாதிரி இருக்கும். Yes, whether it is working or not. Okay, the maximum input I am going to give. What is the maximum input I can give? 1111 1111. Okay, 15 plus 15 is 30, which is nothing but 1110. The first one what I am saying is carry. We'll give small data. 3 plus 3. 3 plus 3 is 6. So no carry. Sum is 0110. If I am giving 3 plus 1, so we are getting 4. So now it is working as adder. I hope everyone understand it. இது மட்டும் நான் என்ன பண்றேன், கேரி மட்டும் தனியா ரெப்ரசன்ட் பண்ணி காமிக்கிறேன், so that you can understand. So now I am going to give input as 15 plus 1, which is nothing but 16. 16 is sum என்னது? 0000, carry வந்து 1. Clear? Okay. Now subtractor அப்படினா என்ன பண்ணுப்பா? The same circuit subtractor ஒர்க் ஆகுனா என்ன பண்ணணும் இதுல? What we have to change? Yes, very good, Sabri. M equal to 1. So now I am going to change M is equal to 1. Fine, I am going to give input as 9 minus 3. What is 9 minus 3? 6. So 0, 1, 1, 0. See here the sum output is nothing but difference. If you are getting carry, it is a positive number. The result is a positive number. Okay, you can neglect it. If there is no carry, it is a negative number. Say for example, I am performing 9 minus 15. See, 9 plus 2's complement of 15 perform panningna, you will be getting this answer. Kindly go through it. For example, 15 minus 5 pandron vechukona. Will be getting 10 as the result. 1010. Is it clear for everyone? That C out, when I am configuring this particular circuit as subtractor circuit, the carry out indicate whether the number is positive or negative. Carry occurs, the result is negative. If there is no carry, if carry occurs, the number is positive. If there is no carry, the number is negative. The result is negative. I hope everyone understands this. Just clear? So this is our experiment 3B. I hope everyone understands this. Yes. Okay. As it is very short session, we are stopping with this experiment. Probably by next week, we may be having lab session in the morning and theory in the evening. Okay, because in short time we may not cover all the experiment in the lab experiments. Right? So if you are having any doubt, you can ask, or raise, you can do.